Hey everybody, it's Ms. Segrist again, and welcome to your first video at home. Okay, we are looking at section 1-2, which is measuring and constructing segments. The first thing that we're going to look at in this section is the segment addition postulate. Remember, a postulate is something that we assume is going to be true and we can't actually prove it, okay? And what our segment addition postulate is going to say is that when I have a segment AC, if I have another point on the segment that is between those two, then what I can do is I can take this piece of the segment plus this piece of the segment and add those two together to get the length of the whole thing. So you will find this in your left-hand column underneath example 1. What I would like for you to do is highlight or box the title segment addition postulate and the equation in terms of letters. So we have AB plus BC equals AC. I also want you to make a note underneath the picture in that left-hand column that when you see AB, okay, with nothing above it, the way that this is read is the length of segment AB. Okay, so that is how that is read in words. Okay, so it is important that you realize that AB is segment AB. All right, when you have a bar over it, you're talking about the segment. When you have AB without anything above it, you are talking about a number. Okay, so maybe the length of this segment is 10. So then AB without the bar over it would be 10. All right, so it is really important right now that you are understanding the difference between how you write segment AB and how you write the length of segment AB. So again, no bar on top means that we are talking about a number, which means that we can actually set up an equation like we have here, because we do not set up an equation with segments. We set up an equation with numbers. All right? So when we're looking at example 1 here, which you will find this in your right-hand column in that example 1 box. All right, and you see that it says B is between A and C, where the length of segment AC is 14 and the length of segment BC is 11.4. We want to find the length of segment AB. So you'll see in your notes that I have step 1, which says draw a picture. So we're going to start by doing that. So next to that, over kind of on the right-hand side of the steps, you are going to draw a picture. All right, it says that B is between A and C. So I am going to get my line tool or my segment tool here, and I am going to draw a segment here. All right. And I am going to label my segment A and C. Okay, because it says B is between A and C. So I know that I am looking at A and C as my endpoints of my segment. Okay? And then B is somewhere between them. So I'm going to put a point B on my line. All right? Now, the next thing that this tells me is that it says the length of segment AC is 14. So I know that the distance from here all the way to here is 14. Okay? Then it says the length of segment BC is 11.4. So that's step 1, is drawing our picture. Okay? So you should have this written down on your paper next to those 3 steps. Okay? Step 2 is to write out the segment addition postulate. And when I say write it out, I mean in terms of letters. Okay? So if I look here, what is the first piece of this segment? It is AB. Okay? The second piece of the segment is BC. and the whole thing is AC. Okay, so if I take this piece and I add it to this piece, it's going to equal the entire thing. All right. So now step 3 is plug in any known values and solve. So we don't know what AB is, so we're going to leave this as just the length of segment AB. Okay, the length of segment BC is 11.4, and the length of segment AC is 14. So we get that from our information up here, and then from our picture once we draw it in. So then we are going to subtract 11.4 from both sides. And I am going to get that AB is 2.6. So the length of segment AB is 2.6. So when I add 2.6 plus 11.4, I will get 14. Okay, so now on your notes, you will see a box underneath this that says questions you have about example 1. Please take a moment, pause the video if you need to, and write down any questions that you have about this. Know that we are going to do another example here in a second. All right, so we're about to go to the next one. So go ahead, pause the video if you need to, and write down any questions that you have. Okay, let's go ahead and take a look at example 2. So we are told here that S is between R and T, and we want to find the length of segment RT. So here's R and T with S in between. They gave us the picture, which you will find in that left-hand column. All right. And again, I've got the 4 steps written out for you, what you need to do. Step 1 is write the segment addition postulate. So again, we're going to start with letters. All right, I want you to consistently start with letters. Every time you do one of these problems, write out the equation in terms of letters first, because I promise you it will help you down the road when we start to get to more complicated things. Right now it seems kind of obvious that, yeah, of course, when you add these 2 pieces together, it's going to equal the whole thing. Okay, but we're going to use that later on in a way that may not be as obvious. So again, it's important that you get in the habit of writing things down correctly. So we're going to start with our segment addition postulate, which is the first piece of the segment, which is RS, plus the second piece of the segment, which is ST, is going to equal the entire segment, which is RT. All right. So now step 2 is plug in any known values and solve. So our known values here is that the length of segment RS is 2x plus 7. All right, that comes from right here. The length of segment ST is 28. And the length of segment RT is 4x. So now the first thing that we're going to do here is we are going to combine like terms. So I'm going to get 2x plus 35 is equal to 4x. All right, then from here, I'm going to get all my x's on one side, so I'm going to subtract 2x from both sides. And I'm going to get 35 is equal to 2x. And then from here, we are going to divide both sides by 2. And I'm going to get that x is equal to 17.5. All right. So one quick thing here is I don't care if you have 17.5 equals x or x equals 17.5. I know in the past you've had some teachers that are very picky about what order it goes in. It makes no difference to me. So just so you know, that you don't have to rewrite this as x equals 17.5. That's fine. Okay, so now we know that the value of x is. So if we look at step 3, it says reread the question and did you answer it? Okay, so did we find the length of segment RT? Okay, we did not. We found the length of x. So now we need to do step 4, which is to find RT. So RT, if we notice, was a length of 4x. So I'm going to have RT equals 4x. Well, we just found that x is 17.5. So I'm going to do 4 times 17.5. And now I know that RT has a length of 70. Okay, so it's going to be important when you're doing problems like this that you don't just find X and move on to the next question. Make sure you're going back and you're looking and you're rereading. Did they want you to plug X in? So remember, because RT has no bar over it, we want to find the length of segment RT. Okay? So again, always go back and reread your question and determine whether or not you need to plug X in somewhere. Okay? Again, underneath this question, there is a box for any questions that you might have. So go ahead, if you have a question, go ahead and pause your video. Fill out any questions that you have. We will go over your questions in class tomorrow. All right? So if you need it, go ahead and pause your video. Otherwise, we're going to go ahead to the next one here. And what I want you to do here is to go ahead and do these two problems on your own. So that means I want you to pause your video, okay? Solve both of these problems. A is just like example 1 that you did. B is like example 2, all right? So we are going to pause your video. You're going to work out these two problems. Then when you hit play, I'll go over the answers for you. And then you can write down again any questions that you might have underneath this on your own example. Okay? So go ahead, pause, and work on these two problems, please. Okay, so here we go. So hopefully you got for part A that YZ was 1 2/3, and for part B that DF was 24. So what you should have done here for A is drawn your segment XZ with Y somewhere in the between those two. All right, labeled XY as 1 1/3 and labeled XZ as 3 from the information that is given to you up here. Then you want to find the length of segment YZ. Again, you should have written your segment addition postulate. If you did not write this out in letters, go back and write it down right now. Okay? Plug in what you know. You subtract 1 1/3 from both sides. Then we get YZ is 1 2/3. Please know that when it comes to mixed numbers, I don't like them at all. Okay? Most of the time, we will use improper fractions and keep it in full fraction form. We will not use mixed numbers very often, but every now and then it pops up actually in the question, and then your answer can be in the same format. But in general, I do not like them, and you will use just straight fractions. All right. For B, they gave us the picture. All right, so we just had to, again, start off by writing our segment addition postulate, which, again, if you did not write in letters, please fill in right now. Plugging in what we know. Combining like terms, so 13 minus 1 is 12. All right, subtracting 3x from both sides, dividing by 3, getting x is 4. Hopefully you did not stop there and reread the question that you're finding the length of segment DF. All right, DF is 6x from right here. And then we can do 6 times 4, which we found over here, which is 24. Feel free to pause the video right now if you need to copy anything down or go over anything or fix anything on your papers. And again, write down any questions that you have on your paper beneath these two problems. All right? So questions on that, make sure you write them down. We're going to go ahead and move on to example 3. All right. Key thing here is we are talking about a midpoint. We've got some new vocabulary coming in, and you will see that vocabulary in the left-hand column of your notes. And we see that a midpoint is exactly what it sounds like. Okay, if I have a segment, the midpoint is the point in the middle. Okay, so it is exactly in the center of the segment. It cuts the full segment into 2 equal segments, or it bisects them. Okay, bi means 2, sect is divide. So we're dividing into 2 equal segments, is bisect. This is a word that you need to know. You need to understand we will use bisect all year long. Okay, I also have in there congruent segments. Okay, so congruent segments are segments that are the same. I can take one segment and another one that's right on top of it here. Okay? Oh, come on. These two segments are congruent. Okay? They are the exact same length. When I put one on top of the other, okay, or close to on top of the other, all right, they're going to overlap so you can't tell the difference between them, all right? They're the exact same length. The way that I write congruent segments is if I say that this is A, B, C, and D. Again, this doesn't have anything to do with our problem right now, just kind of working in our vocabulary, is I would say that segment AB is congruent to segment CD. I would use this little symbol, and you need to make a note of this somewhere on your paper. Don't write in the box on the right hand side though. Maybe put it in the question box if you don't have any. And we'll talk about this a little more later too. But your congruent symbol here is to show that your segments are the same when you put one on top of the other. Now, they may have the same length, which would mean that AB is equal to CD, okay? Geometric figures are congruent, lengths are equal. Okay, so this is going to be a really important distinction between the two. All right, you need to know segments, angles, other shapes that we're going to get to. Those figures are congruent, okay? Geometric figures are congruent. Lengths of the segments are equal. So you need to make sure you're using the right symbol at the right time. Okay, another way we can mark that these two are congruent if we're not told it is you'll see sometimes there's a slash drawn on the segments. That is to show you that those segments are congruent, which means that they have the same length. Okay, so let's look at our example here. It says B is the midpoint of AC. So if B is the midpoint of AC, that means that this segment is congruent to this segment, or that they have the same length. Okay? So when I have a midpoint, I know that these two lengths are equal. So that I know that means that the length of segment AB is equal to the length of segment BC. Okay, those two pieces are equal. So I can set 5x equal to 3x plus 4. And again, make sure you are writing all of this down. All right, so from here, I'm going to subtract 3x from both sides. And I'm going to get that 2x is equal to 4. Okay, divide both sides by 2. And I'm going to get that x is equal to 2. Now, we want to look and see whether or not this is our answer. And if I look here, it doesn't say find the value of x. It says find the lengths of segments AB, BC, and AC. So we're going to start there. So the length of segment AB was 5x. Okay, so that means that the length of AB is 5 times 2. So kind of weird equal sign. Okay, and AB is going to have a length of 10. So there's one of our 3 answers. Okay, then we're going to come over here, find the length of BC. Now, you should know that BC should be 10 because they should be equal. So this is a really good self-check, as if you go through, right, okay, I know that BC was 3x plus 4, okay, plug in what we know. BC is going to be 3 times 2, because x was 2, plus 4. So BC is 6 plus 4, which is 10. So this is a good self-checker to make sure that you have done your math correctly. Because guess what? We all make mistakes. We all screw up. It happens. This makes sure that you didn't mess anything up that was major. Okay? Now, I want to find AC. Well, remember that AB plus BC is equal to AC. That's our segment addition postulate. So we're going to do 10 plus 10 equals AC. So AC is going to be 20. And yes, I actually want you to write it out for now. Okay, there will come a time when you can start shortcutting some steps, but now is not that time. Okay, I want you to write things out, write things fully, because it will get you in good habits for when we need them later. Again, I expect you to look at this and go, oh, well, if this is 10 and this is 10, then the whole thing is 20 without needing to write this down. But again, it's good habit building process for you for right now. So please write everything down. Okay, let's look at one more. And it says that S is the midpoint of RT, and it gives us values for the lengths of segments RS and ST. Okay, so first things first, we want to, since a picture is not given to us, anytime you are not given a picture, your first step is to draw it. So I'm going to draw it. And I'm told that S is the midpoint. So that means it's going to go in the middle, and these are going to be equal. Okay, so S is the midpoint of segment RT. Okay, RS is negative 2x. ST is negative 3x minus 2. All right, so now, again, because I have a midpoint, I know that it's bisecting my segment or cutting my segment in half so that these two pieces are equal. So I know that RS is equal to ST, and I can set negative 2x equal to negative 3x minus 2. Okay, so from here, I'm going to take my, will end up being my larger coefficient. I'm going to add 3x to both sides. And this is going to give me that x is equal to negative 2. All right, so again, we want to check and see, are we finding x, or no, we're finding several lengths. Now, one thing that I want to caution you is that normally a negative answer should throw a red flag for you. That should make you pay attention, because we don't normally get negative answers in geometry, because you don't have negative lengths, you don't have negative angle measures, there's lots of things that we do in here that we just don't do in terms of negatives. So getting a value of a negative 2 should make you cautious. So when we plug it back in, we want to make sure that we get positive lengths. So when we plug in for RS, we're going to get RS is negative 2x. Well, when I plug in here, we found that x was negative 2. I'm going to have negative 2 times negative 2, which means that RS is 4, which is a positive length, which is okay. So that means that so far, so good in terms of my x value. So then I'm going to plug it in for ST, which is negative 3x minus 2. So we're going to do negative 3 times, again, our x was negative 2, minus 2. And negative 3 times negative 2 is a positive 6. So when I do 6 minus 2, I'm going to get that ST is, again, 4, which is what we want. Remember, it's a midpoint, so these two should be the same. Then when I find RT, I'm going to be looking for RS plus ST is equal to RT. And again, I know that you can do this in your head, but for now, I want you to write it down. So it's going to be 4 plus 4 is RT, and RT is 8. Okay, so if you have any questions about this, go ahead and write that down on your sheet underneath this problem. And again, we will go over them in class. I hope you guys have a wonderful day, and I will see you tomorrow.